All right, good morning, everybody. Welcome to the next session of today's Apricot. Today, we're going to be looking on the analysis and resilience of the internet and networks. Our first presenter is Leah Hestina from RIPE NCC, and she's going to be giving us a talk on a look at the root cause of DNS and the key frustrations of the internet users. Please give a warm welcome to Leah. Thank you.
Hello, hello. Good morning, everyone. Selamat pagi. Anyone from Malaysia here? Yeah, 4. Indonesia and other countries. So, my name is Leah Estina. I work for RIPE NCC, and RIPE NCC is one of the 5 internet registry. Our region is Europe, Middle East, and a bit of Central Asia. And in today's presentation, I'm going to talk to you about one of the root cause of for DNS latency, which frustrates internet users most. So in today's presentation, we're going to look at the problem, and then we're going to explore what are the possible solutions and what kind of tools we can use. Okay, let's look at the problem from the user point of view. So imagine you are a user in Malaysia, and then whenever you open a website or you send email to your colleagues in Malaysia, you notice that the DNS query is sent outside the country, or even outside the continent, before reaching the destination, which should be in Malaysia. So this is one of the thing that frustrates internet user most. Because ideally, DNS queries should be able to be resolved locally. But in this situation, if you see the map, the latency can be high due to inefficient routing, and it's not remaining in the country. So now let's take a look at how is the authoritative DNS node of RIPE NCC is reached from the probes that we have in Asia Pacific. So any one of you heard about RIPE Atlas or used RIPE Atlas? Please raise your hand. Yeah, most of you know RIPE Atlas already. So we use RIPE Atlas in order to measure DNS and NSID measurement towards RIPE NCC authoritative DNS service. And we use around 1,400 probes connected in Asia Pacific. And the result that we get from this measurement only from 1,263 probes. So for this measurement, you can do this yourself. Everyone can use RIPE Atlas platform in order to measure any network or any server that you want to measure. And here on the left-hand side, well, on your right-hand side, you will see the measurement result that you can check yourself. You can go to atlas.ripe.net/measurement and the measurement ID as shown here. All right. Let's take a look at the result. So here in this picture, it shows like each color represents the node that we have. So we have some nodes in Europe, and we also have some nodes in Asia Pacific. We have 2 in Japan, 2 in India, and 1 in Indonesia, and 1 in Guam. So if we take a look at this picture, around 50% of the queries got answered from the nodes that we have in Europe. So this is not good, right? I mean, we'll take a look at another picture that shows the RTT. Let's see. So these are the queries that got answered from the nodes in Europe from a specific date, just for your information. So you can see that it's around 150 millisecond until 300 millisecond, although some probes got answered with a low latency, which is good, but in majority, the range is quite high. What about the answer from the probes that, the nodes that we have in Asia Pacific? Let's have a look. So this is the answer that we got from Asia Pacific. 2 nodes in Japan, 2 nodes in India. The latency is around under 80 millisecond. So this is why we want to have authoritative DNS node installed in every economy. So on the right-hand side, some probes got answered with a high latency. They are mostly in Australia and New Zealand, Thailand, Vietnam, and Nepal. So that's why I've been trying to talk to people from Australia and New Zealand here, trying to get auth DNS node installed in this country. So if you are from these economies, talk to me after this talk. All right, let's break it down. Who are affected and where? I mentioned already we have some nodes in Japan and India. Have a look at the top of the list, how many probes got answered from which node. So in Japan, it's doing really well because 156 probes in different networks, they got answered locally. And you know the RTT was around 50 or 80 millisecond, right? But what about Australia? Australia, there's no node there. Most of the answer got from London, Amsterdam, and even one from Venezuela, one probe got answered from Venezuela. So yeah, I'll go crazy if my DNS query goes to Venezuela before it reaches Australia, right? What about Malaysia? Malaysia is kind of similar. We don't have an authoritative DNS node here. So the result is getting answer from various nodes that we have in Europe. And now we've seen, we see Malaysia, we have 13 and 13 probes in Amsterdam and London. The answer got from the nodes that we have in London and Amsterdam. And if we break it down, looking into the RTT, here we can see that one probe on the bottom of this graph is one probe is getting answer from the node that we have in Indonesia, and the latency is quite low, 25 milliseconds, so that's good. And the highest latency is coming, of course, from Amsterdam and London. Here's an example of Australia. It's kind of similar, this similar situation, but what is interesting here in this picture is there are 4 probes. Like if you take a look at down below, there are 4 probes that got intercepted, and the latency is quite low, which is under 50 milliseconds. We don't know what these are. Maybe you know what these are. So DNS ADL04.island OCBB.io. Anyone recognize that? No? Anyway, so Japan is doing really well. Most of the probes got answered in locally, but there are still some probes got answer from London. There are like 48 probes got answer from London, and the latency is quite high. Here's another example. Okay, so now we already identify what the issue is, what the problem is, and now let's explore the solution, or what can you do about it. First thing, try to keep traffic local by hosting AuthDNS node in within your economy. These nodes are any-costed, and if you worry about the security, it's not much different than you know, when you do when you peer with other BGP. So what is AuthDNS node? So this node serves specifically, it serves these zones, RIPE.NET zones, in.addr.arpa. And what makes it interesting and what makes it very important is it's serving the reverse DNS zones of RIPE-NCC, and also as a secondary for other RIR. So like if you, like an example from the beginning, sending emails and stuff, that's why it's very important to have this, to have one locally. It also serves some smaller CCTLDs. So hosting AuthDNS node is quite low effort. You don't need to do much. You just need to provide the server. It's a VM, but it has high impact. I already mentioned about the risk. It's not much different than any BGP peer that you already probably add. And these economies, this is just a small number of economies where we think that it will benefit most by hosting a node locally. Oh yeah, for who it's the best place to host AuthDNS node is an IXP, because then there's a lot of interconnection there, or a big ISP. All right, we talk about the possible solution by hosting one authoritative DNS node in every economy, and now let's talk about you know, routing information service. If you know route views, this is similar to route views. So it provides RIS provides real-time BGP insights from 26 collector that we have connected globally, and we also have thousands of peers. So researchers like Amrish use this RIS data to, you know, to detect if there's any unauthorized misconfiguration or hijack or outages. So with RIS, I like to say RIS in one sentence, like RIS give you visibility. So if you want to, you can peer with RIS, what can you do with RIS? You can ask RIS, for example, hey RIS, is my prefix announced in Malaysia on November 10, for example, and then this data that we collected, all the routing tables that we collected, we show it in tools like RipeStat. Some of you probably use RipeStat already. APNIC used to have APNIC Ox, which is similar to RipeStat. And there's RISLife. Here's an example of how RISLife looks like on the right-hand side. And what's exciting about RIS data is that the community is using this data to build a tool in order to help network operators. This tool is called BGP Alerter, and it's an open source. You can use this tool to get alerted for any BGP, for any prefix that you want to monitor. And we noticed that these economies are still far from our infrastructure. So we are open to for you if you want to peer with RIS data from these economies. All right, we talk about the problem, we talk about the possible solution, and now let's talk about the hands-on solution. I already mentioned about RipeAtlas. RipeAtlas is a global network of sensors. It monitors the internet path in real time, and right now we have around 12,000 probes connected globally. And it uses credit system. It can run 6 types of measurement. And it's accessible through graphic user interface, API, and also a CLI. So anyone can use this internet measurement platform. It doesn't cost you any money. It's for free. You just need to have an account and of course credits. I talk about that you need credits for it, right? So this is how you can use it. First, you need to have an account. If you have an account, you need to have credits. Credits you can get from this voucher. It's around 200,000 credits that you can use. Apricot 2025. You just go to this QR code, and then when you are ready to get started, you go to atlas.ripe.net/measurement, and you can determine yourself. Okay, what do you want to measure? Do you want to measure a website? Do you want to measure your critical server, for example? And then you can determine if you want to run a ping or trace route or the type of measurement that you want to run. And then you can determine which probes you want to use, which network they are located, which country they are located. And then you can determine if it's a one-off or an ongoing measurement. If you just want to test something out, you can do it a one-off. It will give you indication how much credit it's going to cost you. But if you want to monitor whether or not how reachable your network from all the networks that we have, where we have RipeAtlas probes, you can run an ongoing measurement. And then you click create this measurement. And this is the result that you can see an example of the graphic user interface. From this information only, you have a number of information, like which probe ID they are, where are they located, which ASN they are. If you take a look at this picture, if you run a traceroute measurement, for example, you can have a look, hey, this probe in Nepal, it's experiencing like 218 millisecond latency. What's going on here, right? You can click here and then see where the path it's taking before it reaches its destination. So these are the things that you can already do using the graphic user interface. But if you want to build your own dashboard, you can use the API calls and also the CLI tool. All right. So now the challenge. Here you see the map of Europe from how dense is it in Europe and in Asia Pacific. If you compare this picture, if you want to know the big picture, for example, imagine you are trying to understand what's going on in a city traffic, like in Kuala Lumpur. What's the congestion? I've been sitting in a traffic jam, I think a few days ago, going to Kuala Lumpur. So if you want to know what's going on in a city level, but then the traffic cameras, they're only on highways. So how would you be able to know what's going on the streets? So this is the same with RIPE Atlas. The challenge in deploying RIPE Atlas in Asia Pacific region, there's still so many places which are uncovered. And that's why I'm here talking to all of you people, trying to get more probes connected in different networks and also in different type of location. So we want to have more topological diversity. But at the same time, people ask, where do you want to put it? Where do you want to put it, Leah? So as much as, people put it often in a core network, but it's also very interesting to put in end user network, right? I'm sure if you're a network operator or you're a big company, you want to see how do your customers reach you. So if you put it on an end user network, you will be able to see that perspective. We also want to put more in eyeball networks. And the last thing that we want to focus on this year, we want one of our colleague, Emil Aben, he's interested in seeing the interconnection so within the IXP proximity. So if you're an IXP and if you would like to work with us, putting probes within your IXP proximity, talk to us later. All right, I'm at the end of my presentation, and let me just give you an example of what we do with RIPE Atlas data. So we have RIPE Atlas probe, the tiny device, and also it's also available as a VM. But we also have what we call RIPE Atlas Anchor, which is a RIPE Atlas probe on steroid. It tracks measurement. So we have around 800 RIPE Atlas anchors connected globally. And once you connect it, it starts measuring each other. We call it anchoring mesh. And from this data, Emil was able to see what's going on during the Baltic Sea cable cut that happened last year. Just for your information, within Europe, we have a high density. We have many probes, many anchors. That's why we were able to analyze the data. So the result of the research was showing that there were no increased packet loss. There were only around 20 to 30 millisecond path that has increased the latency, only within 20 milliseconds. So, that's why it's important to have more probes so that we can show you this kind of data. And this is the list of the economies where we think we can still put more RIPE Atlas anchors. So if you're from this economy, feel free to install RIPE Atlas anchors. We think that if we have at least 5 anchors per economy in different networks, it will give us at least something, a bit more representative data to do some analysis like this one. All right. We talk about the problem, slow DNS response time that frustrates internet user. We talk about the cause, which is high latency and caused by inefficient routing, and also that the traffic is not staying within the country. And the solution that we talk about is first trying to keep the traffic local by hosting one authoritative DNS in each economy, and then install RIPE Atlas and RIPE Atlas Anchor in different locations, topologically and also geographically, and use risk data. And if you are from the economy that I mentioned earlier, or I showed earlier, you are welcome to peer with us with risks. And the benefit is, it will help reduce the latency. And when the latency is reduced, of course, it will help with the user experience. Nowadays, if people experience high latency, it will change. It can change people's behavior. Like people can just drop it and go to other alternatives. You can use RIPE-Atlas as a tool in measuring this, like the DNS latency or ping trace route, all the type of measurement that I mentioned. And these are the economies where we want to have just a small list of the economies where we want to have authoritative DNS node. And that's the end of my presentation. Thank you for listening in. If you have any question, I'm here until Friday. Thank you.
Okay, do we have any questions?
Hello,
Hi, Eric.
I'm Eric from Interland. Can you go back to the slide 26?
26. Can you point it to 26, please? Probably I click it too fast. Thank you.
Okay. Use RIS data and peer with RIS. There is a small star there.
The star is because we are not open to all. This is just to make sure that because we already have
This is
many
what
peers.
I wanted to ask you to share more, because I know that RIS is paused now.
Yes.
And he's going from open peering to selective peering. And
Yes.
maybe you can share more information about this.
Yeah, so like within Europe, we have already plenty of peers. We want to avoid redundancy, so that's why I put a star there, and I listed the list of the economies within Asia Pacific, and also in LACNIC region, we're still open for peering with RIS, because we just want to avoid redundancy.
Okay, so selective is only in Europe, and
yes,
in
so not
the
in
other regions,
yeah.
it is still open.
Yes.
Okay, thank you.
Thank you. If there's no other question, don't be too hard on me.
No. This is Amrish from ISOC. So you mentioned those countries where potentially we could add an anchor.
Yes.
So can you elaborate more on what are the requirements that people need to have to host an anchor?
So there's a network requirements. The anchors right now, it's available on VM. It should be placed on a stable location. So you can't put anchor at home and maybe in a stable lab probably. But there's a specific network requirements that you can check on the website. Does that answer your question? It's available on on VM only. However, at the moment we have identified a hardware that you can use to install that, but it's not. We don't provide those hardware, and we don't install it there. So you still have to install it via VM.
Hi, Liam. Ed from InkZA. Just one interesting thing I noticed in our South African market with the Auth DNS, because it seems that somewhere along the line, Hurricane is the transit provider for it. Many networks routed via Hurricane rather than directly to one of the closer nodes and shunted to Europe. So I don't know if that's maybe why you have semi-skewed data from the APAC region, because, well, Hurricane peers everywhere and they're quite good at that, but because maybe someone's transit has the route accessible, but they're preferring the route via Hurricane. So
that could be the case. We need to see the data. So I can't answer your question. But let's continue it on email. We can check the data. Thanks.
Hello, I'm Shaoyi. So I just have 2 points. So the first thing about keeping the DNS traffic local, I think sometimes the site owners themselves have to help themselves rather than us just keep deploying this kind of authoritative servers, because some of them set very unreasonably low TTLs even when they are not required. So that causes recursive servers to just keep going to the root, and when the TTLs run out. The second point about this DNS is that we like for example, the iPhone is very popular in Singapore, and there's this iCloud relay going on as well. So some of these queries actually do not even reach the recursive DNS servers at my service provider. So is there any merit or benefit to, like working with big providers like Apple like this to host some of the DNS servers in their network?
That could be that is possible, but with now what I'm showing, we were able, like for example, the Japan situation, right? Japan, we have two auth DNS nodes there. The majority of the probes got answered from Japan locally, but there's still some probe that prefers to go to London. So in that situation, probably if these networks, they need to change their routing policy or put another node in more strategic location that will see those traffic.
Thank you.
Thank you. If there's no other question,
Leah.
thank you.
One last question from Zoom. So we have Liam Steffens. They're asking, could you explain how auth DNS impacts browsing? I only noticed the top level reverse DNS domains and ripe.net, but no other top level domains. Also, it is IPv6, IP6 ARPA, not, there's pointing out a typo, but yeah.
Sorry, what was the question?
Could you explain how auth DNS impacts browsing? I only noticed the top level reverse DNS domains and ripe.net, but no other top level domains.
So the auth DNS serves the reverse DNS of RIPE-NTC. So anything that related to IP address, it needs to be translated, reverse translated, right? So that's what auth DNS does. And for the one, so it serves first the one from RIPE-NTC reverse DNS zones, and as a secondary for the other RIRs. But I'm running out of time. We can continue it in email if that's necessary, if it's needed. I hope that answers the question.
All right, thank you, Leah.
Thank you.
All right, our next presenter is Amresh from Internet Society. He'll be talking about evaluating the DNS maturity for the national cyber resilience. Okay.
Thank you, Jose. So hi everyone, my name is Amrish. I work for the Internet Society as an internet measurement and data expert. And I'm also co-leading the Pulse project, which you might have heard about. On Monday this week, we had our first Pulse Internet Measurement Forum, and some of you were there, so thanks for attending. And today we are going to talk about a project that was done last year. And it is a project that was done within the Pulse Research Fellowship Program, where we had actually someone from Indonesia that worked on this project, which I will present today. So I'll talk about the DNS maturity for national cyber resilience, and we will have a look at what's the situation in Asia Pacific. So of course, you would agree with me that DNS is a very important component of the internet, and a resilient internet is the one that is tolerant to faults. And the DNS ecosystem should also be tolerant to faults, so that you can have a resilient connectivity. So at the Internet Society, we have developed a framework called the Internet Resilience Index, which is made up of 4 pillars, looking at the infrastructure, basically the availability of the physical infrastructure and how resilient the physical infrastructure is. We look also at performance, because you might have a working connectivity, but if it's not performant, as Leah mentioned, if you have very high latency to some services, it is not something that is usable. Security, of course, is important because you do not want your, for example, your traffic to be hijacked or your network to be DDoSed. So we look also at the security hygiene of your network. And finally, and a bit less technical, we also look at how the market in your country is doing. Is it a market which is prominent for more diversity or for allowing other operators to thrive and eventually this benefit to the end user? So these are the pillars that we are currently looking at. Eventually, we might be adding more pillars as needed over time. My colleague Robbie next will do a deeper dive in the Internet Resilience Index, and it will show you the situation in Malaysia and in other countries. So part of this, of the security pillar of the Internet Resilience Index, we have DNS resilience. And we look at, currently we are looking at two main things, I would say. We are looking at DNSSEC, is the CCTLD sign, is the top level domain sign, and what is the level of DNSSEC validation that we currently see in the country. But eventually we would want to expand this DNS resilience dimension in the index to include more things. And this was the whole point of this study. So we look at DNS practices, a little bit inspired by the kindness framework from ICANN. So if you don't know, ICANN has a framework where it sets out a set of best practices for authoritative DNS operators and recursive DNS operators as well. So we inspired ourselves from, let's say, the measurable part of the kindness framework, but obviously not everything. We added a bit of our spice in the source as well. So basically, we're looking at three main things. First of all, redundancy. Do we see duplicate critical components to prevent single point of failure? Do we see good distribution? Usually, the more servers you have to give access to something, the better, because you have more diversity. So here we are looking at physical location and also topological locations of servers, and also diversity in terms of different technologies, providers, again, locations. And also we are going to look at security. So how can we protect the information confidentiality, integrity, and availability? So here, for example, we are going to look whether there is the zone is signed, for example. This is the first step in looking at integrity. So the main question we had is, how can we better measure national cyber resilience based on the maturity of the DNS infrastructure supporting a country? As you know, the CCTLD is very important because it may be hosting a lot of critical services, whether it is the tax service or some other critical services that citizens need to have access to. And if the CCTLD goes down, it's highly likely that you won't be able to have access to those critical services. So what are the data sources that we are looking at? So we are looking at, of course, for each country that we run this analysis, the CCTLDs, but also in a first instance, looking at the top 1,000 most used websites. In the next phase of this research, we are going to look at critical services, for example, specific government services, where are they hosted and how are they hosted, and looking at the DNS hygiene. But basically, we looked at the list of CCTLDs, so we get that information from the IANA root zone. We extracted their name server records. We looked at the IP of those name server records and who is advertising them. So the data on the announcement, we got it from CADA. We looked at whether they are using an Anycast name server, and for that we use BGP tools. And a few of other data sets such as geolocation databases to have access to, for example, where a name server is physically located. And then we came up with a framework. So the framework is made up of a few metrics divided into two parts, critical metrics and the recommended metrics. So critical metrics is, for example, a zone should have at least 2 NS records, 2 name server records. It should have at least 2 unique IPv4 addresses for these name server records and 2 IPv6 addresses for these name server records. Then we go into, for example, do we see different IPv4 and IPv6 prefixes for the name servers? Because you do not want your everything to be on the same prefix. You do not want everything to be using the same AS advertising it. So we also look at which AS is advertising those prefixes. So the numbers on the right column shows like we need at least 2 of those to make it happen. And then we have the recommended ones, which means perhaps they are less critical, but it's always good to have them. For the recommended one, we look at the TLDs. So do we have multiple TLDs, so the name server itself, or is it on only one? And we look at whether they are in the same RIR or different RIR. And then we also look at whether or not they are using DNS Anycast. And based on that, based on those numbers that we have, we then categorize them whether they are having a bad practice, a good practice, or a better practice. So this is just to give you an idea of out of all the ccTLDs in the world, which are the ones that are doing bad, good, and better. So in terms of name servers, having different name servers, most of them are doing okay. In terms of TLDs, we see it is half-half. Half is good and half is bad. So it means that a few of the, half of the ccTLDs are using only one TLD basically in their name server, in their domain. For IPv4 and IPv6 is more or less okay. And for the number of ASN advertising the prefixes we also see more or less good practices over there, maybe to a lesser extent to a lesser extent for IPv6. For Anycast, we see quite good coverage. More than half of them doing they have at least one IPv4 Anycast IP address. For geolocation, this is where it gets interesting. We have good practices and then and also better practices. So blue and orange showing that it is quite okay over there. Now let's look at the top 20 ccTLDs that are performing well. So only a few ccTLDs from countries in Europe, which you see over there, and North America are doing great, but some of them can do better. In contrast, in Africa, there are some countries, for example, Malawi, Tanzania, and some countries in Asia, for example, Thailand and Taiwan, scored lower in terms of their maturity score due to a lack of diversity in the TLDs for their name server. As you can see here, most of them are orange, so meaning that they're doing okay in terms of all the metrics here. But for the name, for the diversity in the TLDs, a few of them are scoring lower score. This is the bottom of the table where you have countries with the least maturity. You have countries such as the Caribbean, Netherlands, and Western Sahara. So we suspect that because these countries are disputed territories and also limited use of the ccTLDs, there's not much infrastructure helping them or supporting them, those CCTLDs. We have also bad practices for North Korea because of the situation in the country. And adoption of technologies such as Anycast and IPv6 are lowest among the CCTLDs that I mentioned. So if we put together those core and we put together a graph, and this is what we get in terms of the most mature CCTLDs. So Thailand, Hong Kong, Singapore, American Samoa, and Bhutan are doing quite well. And the least mature one are Myanmar, Maldives, North Korea, French Polynesia, and the Cook Islands. So this gives you an idea of the hygiene, the DNS hygiene of CCTLDs in the region. Who is using DNS Anycast? A lot of countries in Asia, and this is great, except some notable cases such as North Korea, China, are not using DNS Anycast. So most likely the DNS infrastructure is made in such a way that they are not relying on external parties or DNS Anycast services. Actually, the DNS Anycast services that are being announced as Anycast, this is the from the list of Anycast that we have seen. They are not using any of them. And 3 countries are using only one v4 Anycast address for their name servers. It is Bhutan, Bangladesh, and Cambodia. Geodiversity. So you would agree with me that you do not put all your eggs in one basket. So it's good to have a name server which is outside your country. So let's say there's an outage in your country. Potentially, you can still have access to the one which is outside of your country. And the non-geodiverse CCTLDs in Asia are China, South Korea, North Korea, and Laos. As opposed to other countries which are doing quite well. Philippines, for example, has 5 geodiverse name servers. Thailand has 6 geodiverse name servers. India has 2, and Australia has 3. So these countries are a good example of high maturity and high resiliency. So we introduced domain count as a way to show the level of risk. So obviously a domain which has a very low number of domains, a CCTLD with a low level of domains doesn't represent a big risk. But one, for example, we have the example of .de, for example. They have more than 17 million domains. What if .de goes dark? A lot of domains wouldn't be accessible. So in that case, this is why we use the domain count as a way to show the level of risk. And then we plot this quadrant where on the left side you have the number of the number of domains is on the y-axis, and on the x-axis is the DNS maturity. And you can see which are the domains that are more mature but lower risk. These are in green, in the green quadrant. And in the brown quadrant is the one which is more mature, but they have, and then they are more mature, but they also have more domains. For example, .cn or .in have a lot of domains, but they're also mature. So the risk factor is reduced for them. Those, we are lucky that in Asia Pacific, we do not have one with a high risk and a high number of domain counts. But we do have a few of them. For example, MV is around 10,000 domains and is a less mature CCTLD. So if there is a fault that happens, it's more likely to happen in those that are less mature CCTLDs. So the recommendation would be, of course, to increase redundancy and diversity. Do not put all your eggs in the same basket. Be geodiverse, have geodiverse name servers, have different TLDs for your name servers, have different prefixes and networks announcing your name servers, and implement things such as, of course, DNSSEC and DNSSEC validation for your users to be more protected against DNS poisoning and other type of things. And basically, all these efforts put together would create a more resilient infrastructure for the DNS ecosystem. The key takeaways from this talk: most CCTLDs have redundancy in place, so this is good to see, but we do not see so much diversity in some, especially at the TLD level for the name servers. Some CCTLDs possess a higher level of risk, so they are more vulnerable to downtime, but might impact more users. And CCTLDs might carry identities other than their own national ones, reflected in the number of domains under the CCTLD that are popular with local users. And which means that we all have a role to play, especially network operators and DNS operators. We all have a role to play to make the DNS ecosystem more resilient. Thank you. Questions? Go ahead, Nishal.
Hello, my name is Nishal Gobardhan. I work at Packet Clearinghouse. I'm a almost recovered DNS administrator. I have some questions. Particularly, I want to know how you came up with the metric for low, what did you call it, TLD count,
Yes.
and why you think that's bad. Let me preface my question with my explanation. I'm also a recovering network engineer, and I like to think that I can manage my risk, a lot better than having to necessarily go and ask other people how to do things for me. That's not to say that I don't like to ask for help when I need it. But for example, if I was responsible for my country CCTLD.ZA, I would like to believe that I could make sure that .ZA is online and available in as many redundant, resilient places across the world as possible, rather than go and ask for a name server in, say, .se. And the trend in TLD operations over the years has been to collapse authoritative name server sets to be in bailiwick, right? So something that you're responsible for. If you look at some of the countries that you pointed to, Finland, you'll see the name servers are a.ns.fi, b.ns.fi. I'm speaking from memory, it might be something else. But that actually has been the trend. And it's been considered a good thing because as the operator of .fi or .za, I can manage those risks inherently without having to worry about a whole bunch of other externalities that come in, because I don't know what the .za person is going to do if I have them in my name server set. So this metric that you have where you say that it's bad, one, how bad is it? How did you get to this bad? Is it a metric that you discovered internally at ISOC, or is it something that has gone through DNSOP, GROW, ITF, or something like that? And why do you think it's bad? Because I see other DNS administrators here, and I'm sure that they agree with me that us being able to manage our own risks is a good thing. I don't actually run a CCTLD. Maybe I should start with that.
Yeah, that's a good question. So obviously, no, it hasn't gone through any standardization process or through the DNS community. It is just a research study that we thought that could be interesting. So our aim was to have a score for the maturity of a DNS ecosystem, and so basically we decided that okay, we will give a score like. Is it a bad practice? Is it a good practice? Or is it a better practice? A little bit following the kindness practices as well. So what you say is bad is probably something that you're managing yourself. You say that you're managing the risk. But looking at the grander scale of things, more diversity is always better than less diversity.
No, I disagree with you completely. I'm sorry. What you're saying is your opinion, and I respect your opinion, of course. But I'm also asking you to respect mine, which is to say that if I choose to be in bailiwick for my name server set, and that's a risk that I'm inherently comfortable with, why do you think it's bad? I'm asking you to justify your opinion here. I respect it. I'm just asking you to justify it.
Well, I guess people can have different opinions.
Yeah, absolutely. Yes. Please justify yours.
Well, our opinion is that we stand that more diversity is better. This is our opinion. And that's it.
Okay.
Yes.
There's another question.
I have a question. I've just done a similar kind of study looking at all the zones in the root zone, in fact, the Tranco top 1 million as well. And I was interested in your classification of these zones are formed, served by Anycast. How did you figure that out?
So we were using the Anycast, the BGP Anycast tool, the BGP tool Anycast list of Anycast services that they are providing.
So you have no idea how they formed that list?
I have read about it. I cannot talk about, well, I kind of forgot about it, but it is a list that has been used by multiple other research.
So if I have an Anycast network that has nodes in, let's say, Kuala Lumpur and Singapore, is that Anycast? Versus Cloudflare, where I have nodes in 4,000 locations. Anycast is not Anycast. You know, when you actually peel away it, you actually find that some of these so-called Anycast networks are remarkably constrained and actually look really like Unicast. In fact, some of them are different addresses in the same data center. So when you really want to talk about what is a diverse, dense Anycast network, there's a couple of adjectives there that are not just it's Anycast. It really is about trying to understand the diversity. Secondly, in this entire exercise, you seem to forget the fact, and I'm sorry if I'm being critical, but I think it's really important.
Mm-hmm.
More than 95% of all queries get answered by caches.
Yep.
If it wasn't for caching, there would be no DNS. A really resilient authoritative server sends out records with the longest possible cache TTL they're willing to live with. And that's not 1 minute. It's not 1 day. Make it long and let all the recursive resolvers do all your work for you, so your authoritative server is normally not consulted. And so an analysis of the TLDs by their effective TTLs that they're giving into the caches to get the recursives to do all the work is almost the really big thing to say, this is the way you make the DNS work. And if you're sitting there going, I think TTL 0 is a really good value, the answer is you really are, you don't understand what you're playing with, and that's just crazy talk. So a couple of things when you're trying to score other people's networks, think long and hard about what you're trying to do. Third point, did you study the behavior of recursives? You see, for example, Unbound, when it gets given a list of name servers and IP addresses, goes and actually looks at the amount of time it takes to reach each of them. Theoretically, it goes to the fastest, but Unbound considers that all addresses within 400 milliseconds are the same, i.e., no matter where you are on the planet, it's as fast as anywhere else. So if you're using Unbound as your recursive, it's really, really hard to actually get the fastest because it may be 400 milliseconds slower than the one that's next door. So this kind of study needs to have more breadth and more depth before you go and start scoring people and giving them good and bad, assignations, because I think what you're doing is relatively simplistic and at times kind of flawed. And I appreciate the effort, but I think you need to delve deeper into the way the DNS actually works. Sorry.
Yeah. This is just a start of the study, and we looked at authoritative. We would look at recursive as well. And I totally agree with you that what you mentioned about recursive and TTL and everything, this is totally right. Yeah.
Thank you.
Hello, I'm Anley, come from CNIC. Just simple comments. I just see you cannot find any cast v4 address about .cn TLD. But in fact, there are several Anycast v4 address and at least 2 Anycast v6 address. So I don't know why you cannot find Anycast v4 address about .cn.
That's probably same point that Jeff was saying about the Anycast tool that we use. It might be flawed. So we are using a list that is being provided by us. So we could. This is maybe this is future research as well. understanding or discovering Anycast addresses is an active piece of research, and we use just one of them, which is being made available at the moment.
Okay, thank you.
Yeah.
I think we're out of time for questions. If you guys have any more other questions, maybe you guys can get together and discuss this offline.
Thank you.
But thank you very much, Amresh. All right, continuing our discussion on analysis and resilience on the DNS infrastructures, we have Robbie Mitchell, also from Internet Society.
That's all right. I'll try that. I don't like to move around. I like to stay put. I like to write talks.
The battery's dying.
Oh, that one's going to die? Okay, this one sounds better. I like to write talks. I don't like to give talks. So I'll just stay here. Thank you to the organisers. Thank you, Jose, for the introduction. And thank you all for sitting in here or wherever you are in the world. Today, I'm not going to talk about DNS after that. No. I'm going to talk about two things. The Internet Society's efforts to help decision makers, including network operations community, understand the global internet's resilience. A little bit more of what Amrish touched on before. But the real important thing that I really want to get to is how we need to extend the scope and improve the cadence of how we are measuring and strengthening internet resilience. And I'll use Malaysia as a bit of an example. So before I do dive into Malaysia's resilience, I must acknowledge that this presentation and my growing interest in the topic started over a breakfast catch-up with Paul Louis in the room here in Malaysia about 10 months ago. If you haven't already, definitely get out and try the local breakfasts, take someone with you, have your own little nog discussion. It's a great way to spark interest in things that you might not have thought about in the same way as you did after getting that local experience, I guess. So last year I was on stage, where were we, in Bangkok, giving the presentation and on this Pulse website and the internet measurement project that we're doing at Internet Society. And we've been working on this since 2020. It's not new. We're continually always working to improve it, and we love the critical feedback that we get on it to do that. So the project started out trying to collate all this data and, you know, trying to put it up there for others to make sense of it. So we have also this research component, which Amrish just touched on, one project of many now that we're starting to do with Pulse Research Fellows, which are 6-month projects to, you know, try things, look at things. It's not always going to come out right, but at least we get a little bit more of an understanding of how we can improve the way we are measuring different aspects that we're particularly interested in, performance, availability, and resilience. And the second part of it now is we're trying to get that community awareness. To be honest, we want to work with network operating community and researchers, but really we are trying to get to decision makers, journalists and civil society groups as well. The Internet Society, very diverse audience. Number one, we work with our members like APNIC works with its members. We want to help them do what they want. So it's important to just step back and just remind people that we don't create data. We're just curating data. We're just collating it and bringing it in and trying to make some sense of it. So they're some of our data partners. We need to update that. And most likely you're using quite a few of these for yourself. We do bring this data in and we start to do our own models, one of which I'll show you soon. But again, all the data, it's open sourced, so you can trace it back to its original and do it yourself. By no means do we say that any of these sources are sources of truth, or particular, the source of truth, nor our interpretation should be taken as the source of truth. But we all welcome your feedback with regards to it. But they do form a discussion point. And we hope by collating the data, providing a standardized, digestible view of regional and global trends, it'll help us identify weaknesses before they become critical and allow you to do the research to validate what we are seeing. So one of the trends from what we have done, what we've been looking at over the last 5 years, is looking at internet resilience. And we're able to, from the data that we have access to, create an index for 180 countries. So Amrish talked about some of those different things in terms of the pillars of infrastructure, performance, security, and market readiness. We're always looking to improve this, and we're playing around with also looking at environmental and disaster risk as well. And it's about trying again to see weaknesses for when things happen. And it is the when, because things are going to go oops sometimes. It's natural of any ecosystem. Ecosystems aren't built to be bulletproof. There's weaknesses everywhere. But it's how resilient that system is to be able to keep going when something bad goes wrong, and how quickly it can get that back up in time. I was missing a slide now. Oh, that's all right. This is my second time. So measuring is hard. I've heard Jeff say this over and over and over again. Measuring the internet is hard. And he grins at that. We are taking a stab at this, and particularly measuring internet resilience, which is such a broad thing. We're taking all these different metrics and the different methodologies and relying on them to quite a bit of extent. But resilience is trying to look at it particularly in a holistic manner. And just because of the pervasiveness of what the internet has become, we have to start really considering that this isn't necessarily a routing issue anymore. This isn't about dumb pipes and packets getting from A to B. There's a lot more that is impacting the internet. So I'm going to get to that soon. But the Internet Resilience Index, it offers us a highbrow view of, how everyone's going in terms of their resilience, and gives you a lovely map of the temperature of your resilience. You can dive down into the regions. So we can see Europe is very mature. We all know that. Asia, it's improving to be 48%, and we have half the world's population, and probably half the world land size as well. It's a massive credit to be where it is at 48%. Dive down further into the sub-regions, Southeast Asia, it's coming up. Eastern Asia, again, has a more mature internet landscape than the rest of its neighbours. But Southeast Asia, a lot of growth. And with that, it's great to also see that the resilience is there as well. And Malaysia, so 57%. Another great credit for the growth that's been happening here in Malaysia. I should point out as well with Vietnam as well, Thailand, Vietnam, Malaysia, they've been on similar courses with a lot of what they do. The one big thing that's been mentioned at the conference is the IPv6. That's only one part, but there is a lot of similarities. So you can drill down into the profile, and this is all the metrics that is accumulatively going towards that 57% that I showed you. And you can start to see what we meant by the pillars and the colouring. So for Malaysia, its most resilient pillar is performance. Done a fantastic job, and kudos to those in the room who have been a part of improving the fixed and mobile performance in the country over the last 5-10 years. Second most, market resilience, readiness resilience. And then you've got security and infrastructure. A new feature that we're working on is also looking at historical, so that you can actually track how resilience is progressing over the years. And we can see in Malaysia, it's been fairly consistent. It's been around that 56 to 58, just around there. But you can see that big jump in performance. So from 2019 to 2021, you've done some massive upgrades in terms of the fixed and mobile performance. So it's giving you this, I guess, historical view to be able to then overlay what happened between those years. What did we do right, or what did we do wrong? So again, it's just trying to offer you some sort of, ask the question and then go and validate. It's worth recognising, though, that performance isn't everything. I know that you talk to any ISP and network operator, it's always about speed and performance. Our uptime, no downtime, that's what they're gaining for. And that's what customers like as well. They love to talk about the speed and to make sure that the price is right. But it's not the limiting factor. The limiting factor of the internet is this. It's electricity. If you don't have electricity, nothing works. No matter how resilient your network is, no matter how much redundancy you've got, no matter how many people you peer with, who cares? It's all off. Nothing's working. According to Cloudflare Radar, since 2023, 23 power-related national internet outages have occurred across 17 countries, lasting from 3 to 9 hours. And if you've been on the news today, Chile's currently facing this. They've just experienced a 5 to 6 hour national electrical shutdown, and the internet's down. Check out Cloudflare Radar at the moment. There's a big drop in internet connectivity for Cloudflare traffic. This is only national, though. It doesn't account for those smaller regional outages, which are common to all of us. We've all experienced brownouts, blackouts, and they're becoming more and more common. And that's because infrastructure isn't being made, or isn't being updated, the electrical infrastructure of countries. Now, it's hard to come by that data. It's hard to come by data, first off, on these regional outages and the impact that it has. And it's hard to come by how much they're on the resilience of the infrastructure that's supporting all of your networks. The biggest issue is the cadence of the data. So you can get some data. So this delivery point fund reliability index, this is a standardized metric that's used by the power industry. But you can see that's 2021 data. That's very hard to forecast how you're building your data centers, how you want to grow your network into new markets. do you want to go into that new country based on this sort of data, knowing that if they do have a resilient power infrastructure in place to be able to support your network and make sure that it's going to stay on? It's also questionable about the coverage, and many power and no doubt internet outages go unreported. This challenge of fresh data and live data is not something unique for the power industry. No, this is also for internet measurement data. I mean, we're pulling from sources like the UN and World Bank, and that's reliant on countries updating data associated with performance, associated with internet penetration. That's all related to governments updating that. And you can kind of see the interest of governments in doing that, and potentially also see if there's been changes in government by looking at how fresh the data is whenever you're looking at that. So some of our data, in some instances, goes only back to 2017. It hasn't been refreshed for 8 years. And that's also part of why we can't index the whole world, because the data's not there. This is why we're fans of projects like RIPE Atlas, like UNI, like IOTA, like Cloudflare, that are doing this active measurement, that they're trying to get this live data and make it public, to show what is really happening now, to allow you to test what is really happening now. Because we're becoming more and more reliant on this live data to be able to forecast and show effect of whatever we're trying to implement. While outage data is one thing, production and consumption data is perhaps more critical when it comes to exploring new opportunities in regions or other countries. Again, we can see there's a lag in data, but there is a large gap between these two figures. So we can safely say Malaysia's an okay place. It's not all of a sudden, everyone could double the amount of electricity that they're using right now, and the country's okay. It could handle it just. That said, consumption is growing. It's not doubling like right now, but it's well ahead of its neighbours. And its per capita consumption of 5 megawatts per hour is well above the region average. Businesses consume as much electricity as residents, just generally. So you take that figure and you double it, and you can kind of get a per person amount of energy that for each country. So that comes to about 10 megawatts per hour for Malaysia. Just keep that in mind for a little bit later. We're going to do some maths. I know you all like that. So yeah, industry is the major contributing factor behind this growth. You're a part of that. You're a part of this industry. A report by the ASEAN Green Future Project estimates that the commercial and services sector to contribute to 54% of Malaysia's overall electricity demand by 2050. One of the most prominent contributing factors that they note is the rise of these bad boys and girls. Yes, data centers, the electricity guzzling complexes have quickly become the lifeblood of the internet, and in many ways are contributing to the increased performance and happier internet users that we just talked about before. Malaysia's current data center operation capacity is around 640 megawatts, and it's expected to grow 5-fold in the next 3 to 5 years, with interest in developing it to 11,000 megawatts, which is about 1.1 gigawatts. This growth is thanks to multiple factors, primarily Malaysia's location, and the cost and ease of doing business in the country. Also helps that Singapore put a mandate on not doing any more data centers in the country. So it's just easier to go across the border and set up shop there. Look, there's plenty of positive news about this for Malaysia. Growth, it's great. Economic windfall, fantastic. These are big, big constructions. We were in the AI talk yesterday. You're talking about billions of dollars to actually build these things. And, you know, you get one up against the little red dot neighbour that you have. But there are equally even more questions, some of which wasn't aware of until my coffee catch up with Paul, that you don't really understand until you talk to the locals and see what impact this will have on a country. Sure, these investments will result in economic upside, but who really benefits from having a 1 megawatt, a 10 megawatt, a 1,000 megawatt data center in their backyard? I only learned about 1,000 megawatt data centers yesterday. Didn't know about them. And I actually only learned about 5,000 megawatt data centers that OpenAI are planning on doing in the US. That's 5 gigawatts. That's enough to power New York City, and they want to do it into a data center. So who benefits? Personally, I'd like to be across the border. I'm close enough to be able to use that data center, but I'm not paying the power bill. I'm not paying the water bill. I'm not even going to get to water in this presentation. The math of these massive AI data centers that are coming, these 1,000 gigawatts, 5,000 megawatts, well, 5 gigawatts rather, it stacks up. Even 11,000 megawatts, okay? So that's what's projected for 2028, 2030 here in Malaysia. You do it, that turns out to be about 5.5 to 10 million households. That's how much the average would be powering. And this isn't considering the costs to produce and consume the energy either. Now, I'm not saying data centers will quickly consume all the excess power or water that Malaysia has. And looking at some of these designs, they're thinking about this. They're trying to build in power, to build in water reserves with these large data centers. You have to. You can't be reliant on the data center 2 states over to be able to have power to you all the time. And there does seem to be plenty of policies in place here in Malaysia. They're aware, okay? They're wanting to improve the resilience of the energy sector and sustainability of data centers, all of which align with the country's goal to reduce energy intensity by 45% by 2030 and get to net zero by 2050. Great. Keep in mind, the energy sector accounts for more than 79% of the country's emissions. Much has also been said about the country's privatisation efforts, which have attracted investment and enhanced efficiency and productivity to ensure sufficient supply. You can take what you want about privatisation, and the government has encouraged the involvement of independent power producers to improve reliability of electricity supply and address a shortage of generation capacity to meet demand. The issue with a lot of people point to renewable energies as, you know, that they'll pick up the slack. That'll help us get down to net zero by 2050. But the issue with renewable energy is, such as solar and wind, it's not consistent. And data centers need reliable, consistent energy. Yeah, you can set up your 20 hectare of solar power next door, you also need to set up the battery associated with that. Where are you going to put that as well? And what's the environmental impact of that battery? How long does that battery life go for? The cost of batteries and all that, it works out to be about $1 billion per gigawatt of battery storage. There's big costs associated with these things as well. Nuclear, yeah, that's been talked about in the US. They've got a track record of nuclear. Try and get nuclear started in a country that hasn't had any nuclear ever. You're talking about 30 years just to even get started. That's not going to happen here. Okay. Malaysia has gas. That's probably its future, gas power plants. But again, that's very hard to try and meet that 2050 goal of net zero or even the 2030 goals. Efficiency, that's good. That's great. Trying to improve efficiency is an easy win, really. But you got to get strict about it. I mean, the power usage effectiveness for Malaysia's data centers on average is 1.9. Oh, that's a standard, actually. That's what they need to meet. The world average is 1.58, and excellent is perceived as 1.6. So bring that down, get that down there, and that will really drive efficiency. Little bits will help, but there's a bigger problem. The challenges posed by their growth, data centers' growth, need to be considered carefully, not just from the government's perspective, but also from network operators and businesses' perspectives. You might see a lot of similarities with your own businesses with what data centers need to deal with here. The elephant in the room is AI and what impact it's going to do. It's going to turbocharge these things. The issue is a lot of these companies are looking for hubs. Again, it's like, do you want to actually have one of these hubs in your backyard? The windfall can be big, but what's it really going to cost you in the long run? Now, I don't want to throw shade on the gift horse that has helped the internet explode into the success that it is, but there are some notable questions and various industries need to have with one another, which I welcome a discussion after this. Yesterday, I had a conversation in the hallway with someone about how household solar in Australia, it is been great for some, but there's huge losses of power because you can't pump it back into the grid. The grid wasn't set up to be able to accommodate the amount of solar power. So some options that have been floated are having neighborhood batteries. That sort of sounds familiar, doesn't it, to how the internet's starting to be developed, about getting content closer to the user. So setting up nodes closer to the user, neighborhood nodes. So there's some similarities that we can learn from the utility sector and they can learn from us. But it's this discussion that we got to get going. We also got to discuss about standard measurement systems to improve transparency and continually better cadence. Without this fresh data, we're working in the dark. And something that's critical, like utility data, that seems pretty bad. Mind the pun as well, working in the dark. I just got that one. Didn't mean that. As Anne-Marie said, we all have a role to play. But we should start thinking about it now. We've got to start working with those that support us, because we equally support them too. If you're interested in continuing this discussion in the coffee, reach out on email, follow what we're trying to do with Pulse. Thanks.
Thank you, Robbie. I don't think we have time for questions. Maybe just just 1 minute left on the timer. All right. Thank you, Robbie. So that brings this session to a close, talking about the analysis and resilience discussions. One announcement that we do want to make is that the closing plenary later on will only be in the Diamond Ballroom, so we will not be opening up this divider. So space will be limited. So if you want to be in attendance of the plenary, please get there as soon as you can so that you can have a space to be seated at and join in the discussions. Thank you everyone for joining us on this session, and please enjoy the rest of the conference and see everyone outside for coffee.